Friends, I am Satyendra and welcome back to my channel. So today in this video lecture I am going to explain you a very important question. Okay, so this question was asked in CSIR NET Physics June 2016. So let's read the question. So this question is basically based on electrostatics. Okay, so let's read the question. The two parallel plate capacitor separated by distance x and distance this 1.1x respectively have a dielectric material of dielectric constant 3.0 inserted between the plates and are connected to a battery of voltage V. The difference in charge on second capacitor compared to the first is. So let me explain you. So there are basically, they have given us basically two capacitors, as you can see here. This is the first capacitor and this is the second capacitor. Okay, and both of these capacitors are filled with a dielectric constant. Okay, so the value of dielectric constant is k equals to 3, and for this also the k equals to 3, and this dielectric completely fills the capacitor. Okay, and then they have given us the distance between the plates. So this is the distance between the plates. For the first capacitor the distance is x, and for the second capacitor the difference, so the distance between the plates is 1.1x. okay, and then both the capacitors are connected to the same voltage V. So the amount of voltage that is given to the capacitor on both the side is same, that is V. Okay, so this here also there is V. Okay, so these capacitors are almost similar, they only have one difference, that the difference between the plates. So for this the difference between the plate is x, and for this the difference between the plates is 1.1x. so that's the difference. Okay, so finally what they have asked us is that the difference in charge on second capacitor compared to the first capacitor. So they have asked us the difference in charge on second capacitor compared to the first capacitor. So let us find out. Okay, so right now you have seen that this is the first capacitor, this is the second capacitor. Okay, so now before solving this question you have to know some important concept, and the first concept is that the charge is equals to capacitance times voltage difference. Okay, so this is the amount of charge is given by this equation. Okay, where C is the capacitance, where the C is the capacitance, and for the parallel plate capacitor the capacitance is given by this formula. Okay, in this formula epsilon 0 is the permittivity of the free space, A is the area of the plate. So if this is the plate, then the area of this plate, this is the area of that plate. Okay, and D is the distance between the plates, and T is the, as you can see here also, that D is the distance between the plates, and what here you look is the T is the thickness of the dielectric, K is the dielectric constant of the dielectric. Okay, so this was the dielectric. Okay, and K is the dielectric constant, T is the thickness of the dielectric, and D is the distance between the plates. So in our case actually this dielectric completely fills the capacitor. So here D equals to T, here D will be equals to T. So okay, so let's do it for let's solve this equation for the first capacitor. So for the first capacitor we put Q1 and C1, whereas voltage for both of them is same, so I have written V. Okay, so now you can see that for the first capacitor the value of the capacitance is here. Okay, and here as I already told you that the dielectric completely fills the capacitor. So here you can see that dielectric completely fills the capacitor. So D is equals to T, and it is given that T equals to X. Okay, so using this formula I can write the capacitance in this way. Okay, so on further solving, okay, so on further solving this equation you will arrive at this point. Okay, you will arrive at this equation. Okay, similarly for the second dielectric, that will be for q2, that we will take the charge q2 and that the capacitance will be c2, whereas the voltage is same for both. Okay, and solving in the similar fashion we will arrive at this equation. Here in the second capacitor also, the the dielectric completely fills the capacitor. So d is equals to t, and it is given that t is equals to 1.1x. Okay, so we have put the values and we arrive at this equation. Okay, now the difference in charge compared to the first is this is a difference in charge, and that can be and we can directly put the values from here to, sorry, 1 minute, give me a second. And at this point we can now directly put the values from here and then this value to this value. Okay, now what we have to do, we have to find out the percentage difference, and the percentage difference is given by this formula. What we are now going to do is that we are now plugging the values. Okay, we are plugging the values of q1, q2, q1 from our previous calculations in this equation. Okay, and I have substituted the values as you can see here. Okay, now after putting the values, okay, many things have been cancelled, and I arrived at this point, and you can also solve it, and you can see that you will come to this point. Okay, and then I have taken out 1 upon x common, and then after that this quantity and this quantity will get cancelled out, and we will left with this. And on further solving you can find that you will get this equation, and then you will get this equation, and then you will get this equation, and on simplifying you will get this and this, and this is our answer. Okay, so thanks for watching this video. Thank you very much. If you like my video, please say like, subscribe and share with your friends too. Okay, thank you very much.